So this is our last video on distributions. A table like this shows how frequently each value occurs and is called a frequency table. In this case, it describes the distribution of M&M color frequencies. Not surprisingly, this distribution of frequencies is called a frequency distribution. Often a frequency distribution is shown graphically, as in this figure. The distribution on the previous slide is the distribution of the M&Ms in one bag. You might be wondering about the distribution of colors for all M&Ms. Conveniently, the manufacturer of M&Ms provide these data. However, they do not tell us the number of M&Ms of each color that they've ever produced. Instead, they report proportions rather than frequencies. This figure shows us these proportions. It's called a probability distribution because if you choose an M&M at random, the probability of getting, say, a brown M&M is equal to the proportion of M&Ms that are brown, 0.30 or 30%. So now you've learned two things. One, the only real difference between a frequency distribution and a probability distribution is the y-axis labels, that thing that the arrow is pointing at. The frequency distribution is the count of times something occurs, and in a probability distribution, the y-axis is the percent or probability of the time it happened. Two, there are not equal numbers of each color of M&M. Maybe you wondered about that. If you have a continuous distribution, like this example, with a measured response time with the mouse, how long it took to click on something in milliseconds, it doesn't really make sense to do a histogram because you just get a bunch of ones because each value occurs one time. So in that case, it might make more sense to create a group frequency distribution. This table shows a group frequency distribution for those 20 times where they group them by hundreds, 500 to 600, and so on. Statisticians have developed some mathematical formulas for describing distributions, and you've probably been using these distributions without thinking about it. One you'll hear a lot about is the bell-shaped or normal distribution. That's probably the one you're most familiar with. In fact, there's a whole chapter on it later in the course, chapter 7. You'll notice that the two halves are mirror images of one another. So it's symmetric. And the more extreme a score is, the less likely it is to occur. And that is equally true for extremely low scores or extremely high scores. And it only has one peak. So it's symmetric and has one peak. Distributions have different shapes. They don't all look like the normal distribution. For example, the normal distribution is higher in the middle compared to its two tails. Not all distributions are like that. There's even variations among the distributions that we call normal. And then distributions that are not normal can be asymmetric. They can have more than one peak. Let's take a look at a few. So here's two normal distributions. They're both symmetric. They both have one peak, one here, and one here. If you draw a line down the center of them, don't just pretend that was a straight line. I'm really bad at art. You can see that they're symmetric. So two different normal distributions, one more spread out than the other. The figure he's shown here is a distribution of scores on a psychology test. This distribution is not symmetric. So most of the people are in the middle, but some people did really, really well. A distribution with the longer tail extending in the positive direction is said to have a positive skew. It's also described as skewed to the right. And I always had trouble remembering which was positive or negative skew until I moved to North Dakota. It's the direction you're slipping if you're on ice. So see my person here slipping out that way. That's a positive skew. That is a skewed distribution. This is an even more positively skewed distribution. This happens to be the distribution of incomes of Major League Baseball players in 1974 in thousands of dollars. It's positively skewed. In the US in general, income is very positively skewed. So most of us are over here, and like Bill Gates and Elon Musk and those people are down there. Often grades in graduate school are very negatively skewed. Say this was a 20-point quiz on a test of anything. Graduate students, most of them are in grad school because they're pretty good students. So you see a lot of A's and B's and very few failing scores. And here you see my person sliding off in the negative direction because this is negatively skewed. Most of the scores over here on the positive side, and then skewing out to the negative end. This distribution has two distinct peaks. A distribution with two peaks is called a bimodal distribution. And you might notice this is the distribution of height in inches. And the reason that it is a bimodal distribution is this would be the normal distribution, more or less, for height for women, and you have a more or less normal distribution of height for men. I didn't draw that very well, but this is a bimodal distribution if you put them both together, men and women. And here's something to think about. My advisor in grad school told me this, and it's a very interesting point. Whenever you see a bimodal distribution, ask yourself if it could be two normal distributions put together. So, like I said, that last one is the distribution of height. But when you put together the distribution of height for women, which is normally distributed about the mean for women, and the distribution of height for men, which is also normally distributed for men, you get a bimodal distribution. We'll learn about all this more in later chapters, but for now, we say goodbye to chapter 1 and end our first week.